This video is about how to draw an organic molecule. So organic form molecules are pretty simple. Pretty much consists of just carbon, hydrogen, oxygen, and nitrogen. So what you need to remember is something called a HONC rule. Hydrogen pretty much form one covalent bond, oxygen form 2, nitrogen form 3, and carbon usually form 4 covalent bond in an organic molecule. So what does that mean? That means that if you have something that say like I don't know, C2H6, that means you have 2 carbon, and usually because the carbon can form 4 covalent bond, 4 line, the carbon will be in the middle, so you'd have 2 carbon and then 6 hydrogen that will surround these 2 carbon like so, and the rest would just be, well, these guys have to at least connect with each other by one bond, so you would just make a bond between all of each other. And for this compound, carbon have 1, 2, 3, 4, 1, 2, 3, 4, so it's all set, and hydrogen have 1. So you already satisfied this HONC rule. Now let's take a little bit more complicated example. Let's say CH3COOH. In this case you have 2 carbon here, so I'm going to draw 2 carbon. The carbon are probably going to be in the center. Then H3, this H3 means that all these 3H are connected to the first carbon, so I'm going to write the 3H out. 1, 2, 3, and then OOH. Well, that means that you're going to have an O, and OH means that the H is connected to this O, so you're going to have an O and then an H that is connected to this O. So the first part is pretty straightforward. You have hydrogen can have one bond, so it's probably going to bond with this carbon like so, and this carbon is going to bond with the other carbon, so this carbon is okay. It's got 1, 2, 3, 4 covalent bonds, so it's set. Now the question is, how do we decide how are these things going to bind to each other? So one possibility, and use a different color here. One possibility is you can say, okay, this carbon bind to this oxygen, and then this oxygen bind to the other oxygen, and then that bind to an H. Now, if that's the case, this oxygen have 2 bond, it's okay, it's set. This oxygen have 2 bond, is also set. But the problem is this carbon only have 1, 2 covalent bond. So that's not gonna work. So we're gonna step backward. I'm gonna say, okay, that doesn't work. So let's try something else. Can we try this carbon bond to both of the oxygen? Okay, so far as if that's the case, this carbon have 1, 2, 3. That's not good. You need another bond for the carbon. And this oxygen only have 1 bond, so that's not good either. So what I'm going to do is I'm going to use a double bond instead of just a single bond, like so. So now this carbon have 1, 2, 3, 4 bond. This oxygen have 2 bond. This oxygen have 1, 2 bond. So everybody's happy. One little thing, and you have to remember to do this, is this is a Lewis structure. That means that oxygen have got to have another 2 lone 4 more dots. Now why do we have to draw these 4 dots in order for this to be correct? Well, oxygen have, from the chapter of Lewis structure, you know it have 6 valence electron. So that means this 1, 2, 3, 4 is being shared with hydrogen. Then the other valence electron of oxygen is being shared with carbon. So then now oxygen have 6 valence electrons. So that's the correct Lewis structure.